This section is about transforming quadratic functions. Now, transformations can happen in every type of graph. And so we're going to specifically talk about a parabola, parabolic graph, or a quadratic graph. Now, remember on the side here, I'm going to write the parent function, y is equal to x squared. This is our most basic graph. And so every kind of transformation is going to be affiliated, somehow moved from y equals x squared, and that starts at the origin. Okay, so the first type of transformation is called a translation. Translation is where your original graph moves, it slides up or down, left or right. Now, how is this moved? It can move up or down when a constant k is added or subtracted from the parent function. So it kind of looks like this: your function f of x, and then plus k or minus k. If it's positive, then it moves up. If it's negative, it moves down. Now, when a constant h is inside the function, inside the parentheses, so inside the function. So I think it'll be a little bit more clear when we actually do an example. So if you look down here, your h of x, so that's just to represent a different kind of function, it is equal to x squared plus 2. X squared plus 2. Now, x squared is the original function, and so outside of that you have a plus 2, so your original function, which is in blue here on the right side, if you look on the right side here, the original function, which is in blue, is shifted up 2 spaces. So it moves up 2 spaces. Now this next example, h of x is equal to x squared minus 2, it would be shifted down. So pretty much you just have to look at the origin, and then everything would shift down 2 spaces. Or, I'm sorry, not the origin, but the vertex. Now, if you scroll down a little bit, we'll start to see shifting left or right. So this is the difference here. When the minus 2 and the plus 2 are inside the parentheses, that's when it shifts left and right. So even though this x minus 2 looks like, oh, it should shift left, right because of the minus, it's actually, so inside is opposite. So I'm not sure how you're going to remember that, but I just somehow remember inside is always the opposite, and then outside always just does the normal thing. So here x minus 2 would actually shift 2 units to the right, and then an x plus 2 would actually shift 2 units to the left. So if we look at these two examples on the bottom, example 1a and example 1b, I'll do this first one together, and then the second one I'll kind of assign for homework. So g of x is equal to x minus 3 squared plus 2, and the directions say, describe how the graph of each function is related to the graph f of x is equal to x squared. So here I have one inside the parentheses and one on the outside. The inside, again, I do the opposite, and the inside I know is left or right, and then on the outside I do whatever it says. So the inside, it says x minus 3, therefore it shifts to the right 3 spaces to the right, and it moves 2 spaces up. And so that's it. So any kind of way that you can describe how it's moving. So letter B, I'm going to assign for homework. Go ahead and do that, and then I'll check that when you guys come back to class. A dilation is a different kind of transformation. This is when the graph either gets wider or more narrow from the parent graph. Okay, and that depends on the number in front of your quadratic, the number in front of the x squared. If that number is a large number, which is bigger than 1, let's say, then what we call that is a vertical stretch. So that's just kind of a fancy mathematical term for it becomes more narrow. Now, if you have a fraction as your a, so something between 0 and a, then that's something called a vertical compression, which is another fancy word for it becomes wider. So again, if we look at these three down here, it says describe how the graph of each function is related to the graph of f of x equals x squared. I'll do a and b together. For a, 2 times x squared. This 2 is bigger than 1, therefore it is a vertical, what was the term? Vertical stretch by 2. So I am including the number there. For b, I have h of x is equal to 5 times x squared minus 2. So there's actually two transformations going on here. There's a 5, and then there's an outside minus 2. And so that 5, again, is bigger than 1. So that means I have another vertical stretch by 5. And I have a minus 2. Now, since this is outside and there's no number inside a parentheses or inside the quadratic, that means it's going down 2 spaces. So, I want you to try letter C again for homework and bring that back tomorrow for us to kind of discuss. Our third transformation is a reflection, like a mirror. Okay, now it's either going to reflect over the x-axis or it's going to reflect over the y-axis. When the negative is in front of the entire function, like negative f of x, then it's going to flip across the x-axis. If there's a negative inside my function, then it's going to flip across the y-axis. So let's kind of do a few examples here on the bottom. I'm actually going to do A and C, and then you're going to do B for homework. So for A, I got lots of things going on here. I have a negative, I have a 2, and I have a minus 3. So the negative tells me I'm going to flip. Now that's outside my function. Again, that's not part of the quadratic. So that's outside, so it's going to flip across the x-axis. And then I have a 2 in front of the x squared, so that means it's going to be a vertical stretch, meaning it gets narrow. And then I have a minus 3, again on the outside of my quadratic part, the exponent part, therefore it's going to shift down 3. So those are the three transformations for part A. Let's do part C together. Again, I have a 2 out in front, I have a negative inside my quadratic, and then I have a minus 9. So the 2 out in front means I have, again, a vertical stretch by 2. The minus 9 on the outside means it's going to move down 9. And then since the negative is actually inside my parentheses, that's going to be a flip across the y-axis. So that's the difference there. For B, that's going to be your homework. I want you to come back to class with that. Let's keep scrolling down to the next example. So I actually want to see if you can get this on your own. I'll kind of give you a jump start, for example, 4A and 4B. But you will eventually finish this for homework. 4A says, which of these 4 is an equation for the function shown in the graph? So you got to see a few different things here. My origin is right here, but my vertex now is shifted up 5 spaces. Again, so if it's shifted up 5, think about where that 5 has to be in my function. And then think about, is this a narrow graph, or is it a kind of wide graph, or is it a vertical, whatever it is. And then last thing, is it facing up or is it facing down? Did it flip at all? And so choose A, B, C, or D of what you think it is based on the evidence that you see in the graph, and then kind of give some words below of why you believe that. And for your last example, 4B, this time we give you an equation, y is equal to negative 3x squared plus 1, and think about the different transformations that should occur. Maybe think about that first, write down what the transformations are, and then based on those transformations, choose either F, G, H, or J, and then give a brief explanation. And again, when you get back to class, we'll discuss why, we'll discuss this answer. So that's kind of the transformations. These transformations happen for every single graph. If it's inside the parentheses and it shifts, then it moves left and right. If it's outside the parentheses, then it's going to move up and down. If the number out in front is big, then it gets narrow. If the number out in front is a fraction, then it gets wider. If it flips, then it flips over the x-axis. So all these things are the same. So practice this. You have your assignment. Post it on Canvas. Message me on Canvas if you have any questions.